Hello friends, MoNaCo here. Last lecture in our solutions unit. We're talking about colligative properties today. New word, old concept. So you can understand that the property of solutions change when we add these solutes to the solvents. Because the question that we all know about is, why do we add salt to the roads in the winter? And the answer most of us will say, because it melts the ice. My question to you is, does it actually make the road hotter in order to melt the ice, or does it do something else? Is it adding salt to the ice on the roads? Does that make the ice melt because it warms up, or does it make the ice melt for a different reason? And it's a giveaway, obviously. The answer is that it melts the ice for a different reason, because it changes the temperature at which that water would normally freeze. Let's get into a little details here. Colligative properties for electrolytes. When I say electrolytes, I mean an ionic compound. So these are based on the number of particles that are present in a particular ionic compound. Now, an electrolyte is a substance that produces ions when dissolved in a solution. Because those ions are free to move around, they're mobile. And this, as a result, the solution is able to conduct electricity. That's like what we saw in a previous lab. We added an ionic compound to water, and the light bulb lit up because it allowed the electricity to move from the electrodes. They were mobile ions. This colligative property stuff follows the same concept, but not in the same thing. So don't get confused on this Regents exam. When a solute is dissolved in a solvent molecules surround the particles. This causes the boiling point and freezing point of the solution to change in a very specific and predictable way. So, for example, if I put like a particle into the water, all the water molecules kind of like surround it. They kind of glom onto it and attack it. Okay? This is called solvation. Advanced vocabulary word. So all the solvent molecules kind of surround it in a three-dimensional sphere. Okay? And as a result, since those molecules are interacting, they're not going to behave as they would normally. So again, this is the solvent, and this one would be the solute. And this is at the atomic level, mind you. You can't see this happening, so we have to infer it happening. So we call that solvation. But the act of solvation causes the solvent to change its properties. So solvent changes boiling point and freezing point, BP and FP. So let's look at some of the details. The boiling point elevation. This is what happens when the boiling point increases when the solute is added. So adding salt to water makes the boiling point of water increase. So sometimes people add salt to the water before they make pasta. I personally think it's for flavor, because you'd have to add a lot of salt to get the temperature to rise. But technically, by adding salt to your water, you can raise the temperature of its boiling to about 102, 103 degrees, and it would cook the pasta a little bit faster. Now, freezing point depression is when the freezing point decreases when the solute is added. So we put salt on the roads, causes the ice to melt, not because it gets hotter, but because the ice freezes below zero. Okay, so if it's cold out there at 0 degrees, if you add salt to the ice, it's going to freeze at like -10, -20. And the temperature might not be that cold. So it appears to you and I that it causes the ice to melt. But in reality, it's causing the freezing point to drop, because those molecules are not acting the way that they would normally, because we've added something into them. So adding a solute changes the properties of the solvent. Ionic versus molecular solutes. Why do we salt the roads in the winter rather than sugar them? Because if we could add sugar to the roads, it would do the same thing, but why do we add salt and not sugar? Well, the reaction produced when solute is dissolved in water. So when we add sugar, sucrose, covalent molecule, not an electrolyte, to water, we get C12H22O11 plus H2O. I'm going to have to cut this line down here. We just get C12H22O11AQ, aqueous. So it's just that molecule dissolved in the water. the reaction, the number of moles of product produced. Well, if we had 1 mole of that, we have 1 mole of that. So 1 mole product produced. Now let's look at the ionic compound, the electrolyte, the salt, NaCl. When I take NaCl and I add H2O to it, it does something special because NaCl can break apart. It's ionic. It breaks into Na plus 1, AQ, aqueous, and Cl negative 1, AQ, aqueous. So as you can see, it broke apart. So one molecule broke apart into the ions that made it. So the number of moles of product produced here, we took 1 NaCl and we weighed 1 Na and 1 Cl. So that's 2 moles product. 1 Na plus 1 and 1 Cl minus 1. So you can see right away we got 2 moles of product produced by adding 1 molecule to the water. Now, so why does this all work? Well, the solute that dissolves to form a greater number of products or ions, will have a greater effect on the freezing point because there's more things to run interference. Okay, so remembering back to that original picture I drew with the blue and the black and the red dots. When you add the solute, the water gloms on around it. The more ions that get released in the solute, the more water molecules that get interfered with. If we check out this CaCl2 solid, we add it to water, we get a Ca ion, positive 2, and 2 Cl negative 1. So for a total of 1, 2, 3 moles product. So, I asked the question, why would CaCl be better to use on our ice walk than NaCl? Well, it's better because it produces more moles of ions and would interfere with the freezing point more. But CaCl2, look at all these dollar signs, costs more money. So it's a cost effect issue. We want to use the stuff that gets the most job done for the cheapest amount of dollars. Some of the ice melt, the white pellets, are CaCl2. Now, freezing point depressions, typically speaking, sodium chloride can get the freezing point down to the negative 21 for water. CaCl2 gets it to negative 52. It's always a good idea to have a little CaCl2 on hand for when it really, really cold weather hits. Okay. So let's check it out. The very end of it, that's it. So you got to understand that freezing point and boiling point can be affected by adding solute to that liquid because they interfere with the intermolecular forces. There's 17 and 18, 2 pages of practice, a prep quiz, and an actual quiz on concentration and colligative properties in Castle. So let's make sure we have finished our checklist here. So we have just watched our last lecture notes. We got 2 pages of practice to play around with. Make sure I help you if you aren't understanding it. We've got a lab. We're going to make some ice cream using this colligative property of solutions. You got that quiz on there. And then the only other thing you've got to do for this unit is the examination. So remember, your bell work journal daily is 10% of your overall grade. Record your daily note. Your homework pack, watching these lectures, is 10% of your overall grade. Record all your lecture notes. Your practice pack. Use your homework pack to help you complete the assignments in your practice pack. 10% of your overall grade. And definitely use me, your teacher, to help you out if you're getting stuck. Pogles, those are those standalone activities where, say I'm going to work a part one today, we're working on a Pogle. Labs, there's 3 of them this unit. So if you've missed some labs in previous units, this is your chance to make up some of those minutes. But you got to do the entire assignment with your CEI, or otherwise they're not going to be accepted. Quizzes. Notice how we've changed it. We've put a prep quiz and an actual quiz now. So the idea is do your prep so you know how to do your quiz. So there's not all these retakes this time. Now remember, you got to get above an 80 or it's a 0. I'll give you a retest if you need it, but get above an 80. Now that unit exam is 40% of your overall grade. So if you're not a good test taker, you can still get your credit for the course by doing everything else. Chemistry is not hard because it's hard content. It's hard because there's so many assignments. So thanks for being good students and watching your videos. I'll see you in class, and let's do some practice.